This test we did, as you're saying, you might not pass, so I have to release this. And then what we do for say May. My name's Fred Dorgan, and for the past 30-some odd years, I've been a biomedical statistician at UCLA and more recently the USC Medical. Hey, thanks for coming back. Now remember what we're doing here. We're trying to supplement your knowledge of biostatistical concepts so that you can more critically read your biomedical literature. Okay. What is biostatistics all about, especially clinical biostatistics? Well, first, it's about the concept involved in clinical experimental designs. Secondly, it's about estimation of statistical parameters like means, standard deviations, percentages. And thirdly, it's about making comparisons of things you have estimated using formal statistical tests. Now, to do this and to avoid talking about a lot of medicine before we've really narrowed down some of the specific statistical concepts, we're going to, at least with the next 3 or 4 sessions, talk about a very generic example so that we can concentrate solely on the biostatistical issues rather than get involved in the discussion of any of the medical issues. That all will come at later sessions. We're going to presume we have 2 treatment groups. One group is called the standard treatment group, the other is called a new treatment group. Now, the standard treatment group could be almost anything. It could be watchful waiting, it could be a placebo from a randomized clinical trial, it could be some kind of collection of the current literature, or it might actually be the standard way we're treating patients today. The outcome variable for this will be a dichotomous outcome variable. Simple question. Did the treatment result in improvement in the patient? Yes or no? And we're not getting involved in issues of exactly how we define improvement of the patients at this time. Okay, our hypothesis testing then will be based on presuming the null hypothesis, which is that the standard treatment percent improvement and the new treatment percent improvement will be similar. Technically they say equal, but we mean similar. The alternative hypothesis will be that there's a substantial difference between the 2 treatments. Okay. To do the formal hypothesis test, we have to have a significance level of the test. And unfortunately, we have to take 5% for the significance level because 5% has been so ingrained in the minds of the editors that if you don't take 5%, they'll vigorously object and probably won't even publish your paper. Okay, 2 points to remember. Number 1, the 2 treatment groups. They're presumed to be representative of a much larger patient population. And technically we would say they're random samples from that much larger patient population. Well, you never see a random sample of anything, I don't believe anyways. But it has to be representative of that in the sense that the relationships of the more complicated variables that are related to the outcome variable should be similar in the 2 groups. The second point is, again, and I think I've hinted at this earlier, you don't ever get exactly the same result in 2 treatments. What you're really thinking in the null hypothesis is the 2 treatments produce medically equivalent results. So that from an outcome point of view, the differences are so small that wouldn't cause you to choose one treatment over the other.